So as we begin our exploration of solving equations, you are going to hear me talk a lot about a process called simplify, isolate, solve. And that's going to be a progression that we take in solving any type of equation, starting with one-step equations and working our way up to two-step and then multi-step equations. Now, starting at the very bottom of that progression with one-step equations, the only focus today is going to be on the solve piece of this process. We will actually work this way as we introduce steps to the process of solving any type of equation. So we start at solve, and then we'll move to isolate, and then we'll introduce the process of isolating as the step before solving, and then we'll move on to simplifying as the step before isolating and solving. But for today's lesson, we only have to focus on the one step of solving an equation with inverse operations. So what is an inverse operation? An inverse operation, as some of us should know already, is an operation that undoes another operation. So we should know by now that adding and subtracting go hand in hand and multiplying and dividing go hand in hand. So with that being said, we should know that the inverse of addition is subtraction. Likewise, the inverse of subtraction is addition. Those two will offset each other or undo each other. And likewise, with multiplying and dividing, the inverse of multiplication is division. And the inverse of division, of course, would be multiplication because those two go hand in hand. So why this is so critical to know is because when we start getting into solving one-step equations, all that we're going to need to do is to identify what operation is present already in the equation, and then use its inverse by performing that inverse operation to both sides of the equation. Now, it's important that I stress that what you do when you perform an operation to an equation, you perform it to both sides because an equation is essentially a scale. So if you think about this being a scale right here, there's a balancing point called a fulcrum, and the equation sign acts as that fulcrum. So right now, this equation of w minus 3.6 is perfectly in balance with its solution of 2.7. And I want to keep that scale in balance at all times. So if I start to do something to one side of the equation, it's going to tip that equation out of scale or out of balance. So I want to make sure that I do what's necessary to both sides to keep things in equilibrium, to keep things equal. So that's just a fancy way of saying, by the time we're done, what you do to one side, you do to the other. So let's go through and look at this equation. So we see that there's subtraction. We see that there's subtraction right there. And we know that the inverse of subtraction is addition. So if the equation starts by subtracting 3.6, then it would reason that I'm going to have to add 3.6 to both sides to get this w all by itself. The key here is we want to solve for w. That's what we're solving for. So the nature of these operations, subtraction, addition being inverse, allows that 3.6 to cancel, allows us to get the w isolated on its own, fully solved for, and then we can just either by hand or with the use of a calculator add the 2.7, 3.6, and we will get 6.3. Now this brings up the next critical step, it's checking. Now, some teachers along the way will make you feel like that you have to do twice the amount of work. You need to do the solving part and you need to do the check part. Now, I'm going to show that checking just one time here so you understand why this 6.3 will make this equation true. Well, because if I put the 6.3 back in for w and I subtract the 3.6 from it that the equation requires me to do, and either with a calculator or by hand, I should get the solution that the equation claims of 2.7, and I do. So whether you do that mentally or with a calculator, or you choose to physically do it, on paper as a separate process, it is your way of putting your stamp of approval on your final solution. So enough said about checking. So from here, we're simply going to go through some of these other equations. reminding you that the process of solving a one-step equation is really straightforward. Identify the operation. In this case, I identify that fraction bar as division. So then use the inverse operation of division, which will be multiplying. Perform that operation on both sides, and specifically multiply both sides by 3. Why 3? Well, it's because I need to undo the fact that n, what we're solving for, is in the equation being divided by 3. So we use the inverse of multiplying by that same number. My 3's cancel, and n will equal 45. And if you did a check either mentally or with a calculator or by hand, you would indeed confirm that solution is correct. So I think you're getting the hang of this, so much so that I will quickly set up but not solve the next two, and then I'll leave the remainder of the worksheet for you to do. So one more time, I see that there's addition happening in the equation. So I need to use the inverse, which would naturally be subtraction. I have to undo the adding of 32, so I have to subtract 32 on both sides. And I'll leave it to you to finish up solving for x, being mindful of your signs here. So make sure you make use of your negative button on your calculator, or maybe use a little bit of KCO, keep change opposite, to keep better track of -3 minus 32. And then one more problem I'll set up for you, 7y. We should understand there's an invisible multiplication sign, so that really means 7 times y. So if y is being multiplied by 7, we will undo it by dividing. Now I like to use the fraction bar to divide, and I will make sure I do it to both sides. I'll cancel my 7's out, and then I'll just have to make sure that I perform my operation of dividing, taking account for the negative sign as well as I go. So make sure one more time you know how to use your negative button on your calculator, or you make use of your signs accordingly when, or your sign rules accordingly when you're dividing. So your task right now is to simply finish up what I've set up for you in the middle two problems and completely go through the process showing your inverse operation performed on both sides and solving the last two. You'll bring this handout back into class and we will continue our discussion and further practice and exploration from there.